When we think of major public works in Venice with projects like the Mose, we can't help but count the integrated Fusina project amongst some of the more important. A 9,600-metre-long underwater pipe, measuring 1,400 millimetres in diameter, will transport treated sewage to a depth of 20 metres. Research Limited has put the Mantovani Group in charge of the project. The pipeline starts from the Venice Lido, near the Fusina water treatment plant, where urban sewage from the lagoon is collected. From here, once it has been treated, it will be directed via the underwater pipe into the Adriatic, thus providing this area of the sea with more nutrients, which will increase fishing. The pipe is made from 24-metre steel strips, which are coated on the outside with polyethylene and inside with epoxy resin. Laying a pipe of this size requires state-of-the-art ships, a team of experts and technical staff capable of coordinating their work with scientific precision. Research has all the above. The laying vessel is called the Mario Primo, and the technical director, Salvatore Bisanti. The technique used to lay the pipe is a slow one, without a tensioning device, which is achieved by using the Mario Primo as a lay barge. And this is a somewhat novel approach given the position and size of the vessel and the morphology of the area it's working in. We must not underestimate the engineering expertise of the technical staff from Research Limited. Research Limited are the owners of the motor vessel, the Mario Primo. It is 60 metres long, 16.2 metres wide, and has 4 metres worth of ramp. Two 1,500 horsepower motors drive the vessel to a cruising speed of up to 10 knots. Its total surface area is 500 metres, and it can accommodate 8 crew members and 20 technical staff. 4 hydraulic poles mean that the vessel can be positioned and anchored like a platform on the seabed, up to a depth of 25 metres. 5 15-ton winches with their 750 metres of cable mean that the vessel can be easily moored. In the engine room there's a 300 kilowatt generator, 2 150 kilowatt auxiliary generators, and a group of 50-watt generators as well as the engines. At the front of the vessel is the 200-ton excavator crane. It's a Liebherr HS 895HD Litronic. It has a 900 horsepower motor at its core and can be used to do practically anything. The vessel has single and double rooms, all with toilet, wash basin, TV, phone and air conditioning, and offers accommodation for up to 30 people. There's also a fully equipped self-service kitchen, which is capable of producing up to 100 meals a day. The workshop is situated on deck. It has all kinds of equipment, welding tools, soldering irons, pliers, grinding wheels, calendars and other tools. Safety is the prime concern on board the Mario Primo. A hyperbaric chamber is ready for use in emergencies. On board the Mario Primo, there are 2 work shifts, the day shift and the night shift, and 4 or 5 lengths of pipe are laid during each shift. The underwater pipes need to be laid inside a tunnel, which is 10 metres wide and 3 metres deep, as we can see on the radio positioning screen. The Pontone Federico vessel, which is 150 metres ahead of the Mario Primo, is responsible for digging the tunnel. Before the pipe is actually laid, the route the pipe will follow needs to be carefully traced. First of all, oceanographic readings are taken of the area immediately around where the pipe should go, using a side-scan sonar and magnetometer to find out the lay and nature of the seabed there. This provides information about the nature of the sediment and the position of any rock formation, and means that the best possible position for the pipe can be chosen so that drilling work is as problem-free as possible. Once the route has been decided, An underwater search is carried out by divers who are experts in marine biology. It's important to know if there are any wildlife habitats or populations that need to be avoided along the proposed route for the pipeline. Once the exact position has been marked on the oceanographic section, work can begin. The Mario Primo can now put all its resources to work. On the right side of the Mario Primo, you can see the tiltable installation frame for assembling the different sections of the pipe. The frame is a mobile structure which can alter its angle of tilt from the level of the tunnel, depending on how deep the pipe needs to be laid, the kind of piping, and the level of elasticity that's created in the piping as it's being laid. The real selling point for this system is its flexibility. The angle can be quickly and easily changed depending on meteorological conditions. This kind of pipe-laying system looks at first glance to be pretty intuitive, but it is in fact highly sophisticated, the fruit of careful research into ship design and pipe and hydraulic engineering, and is based on data collection regarding the specifications of the piping and the area where it's to be laid. The technical staff at Research Limited, including the engineer Luca Ciaravino, aided by highly qualified consultants like Pier Antonio Quirici, Graziano Fallopa and Sergio Ambrosio, have analysed numerous aspects of the project, including the mechanical parameters of the pipe, the positioning of the pipe, the environment in terms of acceptable wave height and speed of current during the various phases of the work, and the special equipment necessary in terms of ships, etc. The side installation frame comprises two steel lattice girders which form the walls of the work area, with the scaffold base which the pipes rest on during the welding phase. The frame tilts around a carefully determined axis and is controlled by two pistons, one which is run by a precise hydraulic system and the other mechanical. The pivot comprises a cylindrical section shelf which is attached to the main structure of the Mario Primo. The pipes are positioned on a series of rubber-coated rollers with elastic supports. These are placed at varying intervals along the ramp depending on the load, and this is determined by the weight of the pipe and the dynamic forces at play, and these vary according to the depth the pipe needs to be laid at. On the ramp, there are 4 counterbalance structures above the pipes, each of them comprising 2 weights activated by adjustable hydraulic pistons. On each weight, there's a rubber roller to help the pipe, which is resting on the ramp, to move freely along its axis during movements of the ship. The Mario Primo is anchored in 4 different places and is positioned on the seabed thanks to these 4 steel poles. But nonetheless, it can oscillate vertically, and so, if the piping was to be held fast in tight clamps, this could give rise to uncontrollable forces. All the counterbalance weights can be raised and fixed in an open position at the top. In this way, there's enough space for the pipe to be soldered. The pipe is lifted onto the ramp by the tug ship's crane. The pipe sections are laid non-stop. The design of the Mario Primo means that assembly work can be carried out as if it was on a normal factory floor. The steel poles, measuring 25 metres in length, which use a hydraulic activation system, hold the Mario Primo firmly to the seabed.